Hi everyone, and welcome to our video on evaluating non-special unit circle values using a picture or a calculator. Okay, so this one will be just the picture part, and then we'll do the calculator in another one. Okay, so in this problem, it gives us a graph of a unit circle where each of those dots on the unit circle, I'm going to mark them in blue, are 1 radian apart. So they're saying from here to here is t equals 1. And then from that dot to this dot is also another length of 1. Okay, so that little segment is 1. I'm going to say at the end point would be, well, t equals 2, because 1 and 1 adds up to 2. And then one more time, and then I think I'm going to erase this. So sorry, maybe should have said that first. Okay, so that's a length of another 1. So adding another 1 to 2 tells us that's 3. Notice that right here, I'm going to mark pi. So that's halfway around the unit circle. Notice 3 is just short of pi. Okay, so usually we have values that involve pi, but we don't have to. So it's still just kind of estimating where other values would end up on the unit circle. Okay, so we have our t values. Now I'm going to raise, actually I'll just keep that there in case you copied it anyway. Okay, so it keeps going though. Let me mark that in blue. So this is where t equals 4 would be. T equals 5, t equals 6. And then t equals 7 is unknown. We could try to kind of place it. Maybe it's about there. Okay, so it's measuring another length. Okay, so anyway, but we don't, I don't, okay, so actually we do seem to need it. Okay, so let me go ahead and mark it. Okay, so from t equals 6, if I were to go a length of 1, I think that would put us about there. Okay, so, and it keeps going around and around and around and around. All right, anyway, so now that we've got these broken down, well, those are based on terminal points. And if we have terminal points, we could figure out them based on the x and y coordinates. Okay, so our first one, let's mark this in red. So cosine of 4.5. Okay, so 4.5, so if t equals 4 is down in quadrant 3 and 5 is in quadrant 4, well, 4.5 should be somewhere in between. It's maybe about there. Okay, and we'll estimate it. I can make my dot extra big and then try our best to figure out those x and y coordinates. Okay, so the cosine, so I do want the terminal point. I am in quadrant 3. All right, so the next thing I do need to figure out is, well, the scale to this picture. All right, well, it looks like it goes 1, 2, 3, 4, 5. But remember that this is the unit circle, so that point where it starts, that is the point 1 and 0. So it's not 5. So it is 1. So that means I need to break down 1 into 5 parts. Well, 1 into 5 parts is 0.2. Okay, so that means this is 0.2, 0.4, 0.6, 0.8, and then 1. Okay, and it looks like it's the same scale on the x and y. All right, so now that we've got our scale down, I can go back to this point that I've got marked in red. Okay, so this is t equals 4.5. But the terminal point looks like, I don't know, maybe negative 0.25. So it's a little left of 0.2. So, and as long as you're in the ballpark, it's fine. It doesn't have to be exact. So as long as you're not saying like negative 0.8. Okay, so to the left, a little bit left of 0.2. And then down maybe like 0.95, negative 0.95. Okay, so it's pretty close to negative 1 down there. Okay, and then now I'm looking at my whole cosine function. So the cosine of 4.5, that's saying take your x value only. So this is about negative 0.25. Okay, so using this using this graph is how we found it. And this was a way that they might have done it without calculators. So sometimes in math we like to go old school. Okay, so like 50 years ago, 100 years ago, and do it without technology. Okay, so that's what we're doing here. Tangent of 7. Okay, so that's where we marked before. Let me do that in a different color. I'm going to do purple. Okay, so we've got, there's where t equals 7 is about. That's what I'm estimating. Okay, because from where t equals 6 is, I'm saying that length is about 1 in the purple that I just drew. I think it's kind of close to the same length of 1 that's going around the circle. Okay, so I think that's a length of 1 right there. So there's our t equals 7. Let's mark it in purple again. Okay, and then now again, all I'm doing is trying to figure out those coordinates. All right, so where t equals 7, the terminal point, it looks like maybe 0.7. Okay, so it looks in between 0.6 and 0.8. So I'm going to say 0.7. And then my y-coordinate looks like 0.2, 0.4, 0.6, maybe just a little bit above. For estimation purposes, I'm just going to say 0.6 to make it a little easier. Okay, so maybe my dot is right around there. Okay, so again, it doesn't have to be perfect. You can maybe do another decimal place if you want. Okay, but now we can go back and do our tangent of 7. Remember your tangent? So mark it down below. So tangent of this 7 is the same thing as the sine of the 7 over the cosine of the 7. And sine of 7 is based on the y-coordinate. And the cosine of 7, so that's a 7, it looks a little weird. There we go. So the cosine of 7 is the x-coordinate of that terminal point. Okay, so our y-coordinate was 0.6. Our x-coordinate was 0.7. So we have 0.6 divided by 0.7, and we could plug that into a calculator to get a decimal if we need to. I'm just going to write it as 6/7 for this problem. So 0.6 and 0.7, we could just move the decimal over. So I'm just going to do a fraction, and then that's it. Okay, so that's how we can use this table, or use this graph, not a table. So using the graph. All right, but more importantly, using a calculator is what we would probably do more often than this table. This is kind of abstract. Okay, so we're in this last video, the previous video, and this video, we're kind of doing some things that are a little bit it's kind of side notes to the trig. The main thing is, again, be able to evaluate trig functions like these. So from a previous video. So that's kind of the main focus of this section. But I mean, there's some little other things too. Okay, but let's do the calculator in a different video. Thanks for watching, and I'll see you again soon.